Hello friends and welcome. Let's take a look at 8 examples, I believe, of factoring using the difference of squares pattern. So remember the pattern states a squared minus b squared equals a minus b multiplying a plus b. Let's take a look at some examples. So I have here the first one. That will be x squared minus 4. That's a perhaps very simple one. So first of all, the goal is to recognize the a and b, so they can be plugged into the pattern. So when I do that here, I will have x squared within parentheses just to emphasize that x will be a. And then the 4 I will rewrite as 2 squared, where the 2 then will play the role of the b. I hope you can see that. At the next point, we can plug this into the pattern, so it'll look like this. You're going to have x, and then minus 2, and then x plus 2. So the x plays the role of a, and the 2 plays the role of b. So it's x minus 2 times x plus 2. Let's look at the next one. So the next one will look like this. I have 4y squared minus here 25. Again, I got to identify a and b, key points. So to do that, I'm going to have the following. I'm rewriting the 4 as 2 squared, the y squared stays, and the 25 as 5 squared. Now take a look over here. At this point where I have the 2, so where it says 2 squared and y squared, the 2 is the same exponent, so you can pull it outside of parentheses at the top of it, so to speak, where you would see an exponent normally. So it's going to look like this. It's going to say basically 2y within parentheses, that whole quantity squared, minus 5 squared. Again, I deliberately place things in parentheses to emphasize the following. That this will give us the following answer. Now take a look. This is going to be my 2y. And that will also be 2y. So and then that will be negative 5, and the other one will be plus 5. And that's coming from the fact that the 2y plays the role of a. So that goes in those two positions where the arrows are pointing. And the 5 plays the role of b, so that goes in those two positions where the blue arrows are pointing. So it's 2y minus 5 multiplying 2y plus 5. Let's look at the next one. So it's going to look like this. I have here z squared, d squared minus p squared. Same principle applies. So I'm going to do the following. zd, and then the whole quantity squared. I'm pulling the exponent of 2 to the top. And then minus p squared. And then the zd basically plays the role of a, and the p plays the role of b. So you can apply the pattern. So when you do that, it will look like this. zd in those two positions. And then I'm going to have minus p and then plus p. So that's coming from here. The zd plays the role of a, and then p plays the role of b. Let's take a look at the next example. So here I have a plus b, the whole quantity is squared, and then minus 4. Let's work this out. We follow the same pattern as we have been doing. So first we're going to rewrite this so we show two quantities squared. So I'm going to have a plus b squared, that's already done, and then the 4 will be rewritten as 2 squared. Now from here, the next point, I'm going to proceed as follows. The a plus the b plays the role of a in the pattern, and the 2 plays the role of the b in the pattern. So I'm going to have a plus b, and for now, just enclose it inside of parentheses, and I'm going to have minus 2. That's the first piece. Then after that, I will have a plus b like that, and then plus 2. Just to emphasize this point, take a look. The a plus b comes down to that position and that position, and the 2 goes in that position and in that position, where the green arrows are pointing in the blue ones. Lastly, you don't need the inner parentheses. Some people sometimes write them at step number 3, so that's why I included them. So you drop those inner parentheses and you have a plus b minus 2, and then you have a plus b plus 2. And that would be the factored form of the original expression. Let's take a look at the next example. So I have here the following. So 36y squared minus 25x squared. Again, you want to make it so it conforms to the pattern. So I'm going to rewrite the 36 as 6 squared. The y squared stays for now. 25 is 5 squared, and the x squared stays for that piece. At the next point, pull the 2 on the 6 and the y and the 5 and the 2. And the x rather, pull that up to the top. So it's going to look like this. It's going to be 6y, that quantity squared, and then minus 5x, that quantity squared. So I'm using the basic laws of exponents at these steps. And then I identify that 6y is basically a, and then 5x is b, and I stick into the pattern. So I'm going to have the following. 6y in this position, and then 5x in that position, and I repeat. I'm going to have 6y in that position, that's a, and then 5x in that position, positive 5x. So the answer is 6y minus 5x multiplying 6y plus 5x. So now I will have the following. 1/100th of p squared minus 25. Again, you want to factor this. So first is the following. We write the 100 as 10 squared because 10 squared is 100. Put the p squared down for now, and we write the 25 as 5 squared. Now you observe over here that you have a 2 on the 10 and on the p. That means you can just pull that to the top of a parentheses as its own exponent. In other words, you're going to have 1/10 p and the whole quantity squared minus the 5 squared. At this point, I recognize 1/10 p as playing the role of a and the 5 the role of b. So when I do that, I will have the following: 1/10 p minus 5, and then I will have 1/10 p plus 5. So this is my a essentially. This is my a also in that position. Then I have the b, which is -5 and +5 here, the way you see it. Let's look at the next one. So now I have -n squared plus 36. Now this is not a difference of two squares if you think about it carefully, because as you can see, you have -n squared plus 36. This could be done in a couple different ways. You could do 36 minus n squared, and then it would be a difference of two squares. Another thing that you can do is simply observe that you can factor -1 from the n squared and the 36. So when you do that, it will look like this. For now, I'll be explicit with the -1, and then what's left within the parentheses is n squared minus 36. When you factor a -1 from each term, you change the sign. So since this is -n squared, now within parentheses is positive n squared, because it's 36 positive within parentheses after factoring -1, it becomes -36. Remember, the reason is if you distribute the -1 in front, it's going to give you back -n squared. -1 times -36 is positive 36. That's why you can do that. So at the next stage, it's going to look like this. Now I have n squared minus 36. That is a difference of two squares. So I'm going to write it this way: n squared minus 6 squared, and I plug into the pattern. So it's going to give me here n minus 6 and then n plus 6, like that. And the arrows tell you where each piece goes as usual. Let's take a look at one last example. So let's look at the next one. That looks like x minus y. When you look at this, it definitely does not look like a difference of two squares. It is a difference, but not apparently of two squared quantities. So that pattern that we have would not seem to be applicable, but it is, as long as you can rewrite the expression the right way. So let's review something that you can do. Take a look. First of all, when you have a quantity a, like that, without any root symbol, without anything, you could take the root and then square it. Why is that allowed? Because the root and the 2 would cancel away, and they would give you back a, which is the original starting quantity. You can make use of that as follows. In our expression, I'm going to take the x, I'm going to write it as the square root of x squared, because the 2 and the root would cancel off. It would give back the original x. Why would I want to do this? Because this will allow me to transform x minus y into an expression that looks like a difference of two squares. At the next stage, I'm going to repeat that for the y also. So I'm going to put the square root of y squared. Again, this 2 and the root symbol would cancel off, giving back the original y. So I'm making the expression look different simply because now, as you can see, it looks like a difference of two squared quantities, the root of x squared and the root of y squared. And then I can apply my pattern. The pattern will say the following: the root of x, that's coming from here, minus the root of y, that's coming from there, multiplied by the root of x again, that's another root of x, and then plus, rather, the root of y. And it looks like this. In other words, it doesn't seem like something factorable about step number 1, but it actually is, into this form. Okay, and that is it. Thank you so much for watching. I went through this kind of fast, but I wanted to show you that a whole bunch of different examples. Hopefully this has covered a lot of what perhaps you've been looking for. Thank you so much for watching. Please leave a like and subscribe, and I will see you in another video.